Hello, initial participants. Hope you're all doing well. We're just gonna wait a little bit for more participants to show up. In the meantime, we have a chat and a QA. Feel free to say hi in the chat. I'm actually interested in people's backgrounds and why they came here, so wouldn't mind posting like a one sentence. This is my experience with tracing or OTel, and this is what I'm curious about. That's always helpful. I'm happy to tailor this to your questions. And I'm going to share my screen, but just let people know I'm not going to put this into presentation mode because that lets me actually hang out with you all in the chat and the Q&A. And we'll wait just one more minute for people to get to show up. But I do see we have 5 attendees so far, which is great. And again, it would be great to hear from you all in the chat or the Q&A tool. So if you're new to Zoom, there are some buttons along the bottom. One of them is like 3 dots, and under that you'll see chat. That'll take you to the chat window. There's also a Q&A button. If you see that, that's a place to ask questions. So if you do have questions during this, please put them in the Q&A section. And I'll be monitoring that as I go through. And I would prefer to actually have this be more Q&A focused. So as I'm going along, please ask questions, and I will be monitoring that Q&A, and I'll be stopping periodically to answer them. But hopefully everyone's having a good Thursday morning or whatever time of the day it is in your time zone. And just to give you a little bit of background about myself, my name is Ted Young. I work at Lightstep, but I'm 100% OpenTelemetry focused. I'm one of the co-founders of OpenTelemetry. I come from the open tracing side. I'm on the OpenTelemetry governance committee. And of course, I've been working on this, and I'm really excited for OpenTelemetry to GA very soon. So we'll be talking about a lot of that, but I would love to hear from you all and hear a bit about your background. So if people wouldn't mind just saying hi in the chat, and let me know, like, do you have any experience with OpenTelemetry or distributed tracing? Just what it is that brought you here would be super helpful to know. I'm going to type that in the chat. And if we got a quiet crew today, that's also okay. Okie dokie. Well, why don't we get started then? So here's our schedule for today, just so you know. So we're doing intros right now. The next step is to set up a Lightstep account. If you don't already have one, we have free developer accounts for precisely this purpose of playing with OpenTelemetry. Then we're gonna do an overview, some Q&A. Oh, why does this say go? Sorry, derp. At least someone is paying attention. Yeah, this is in fact for Node. Sorry, I use some of these slides for different presentations. I just hadn't changed that from the Tuesday presentation. So here we go. Yeah, the initial part of this slide deck isn't Node specific, but we will get into a tutorial and a code walkthrough. We'll hopefully have Matt Weir, one of the Node.js OpenTelemetry maintainers, jump on the call to help out with that part. But let's get started with the overview. So the first bit is to please create an account. So this will help you try out the walkthrough code. You do have to have an account with Lightstep or some other tracing backend in order to use OpenTelemetry. So if you have your own setup, that's also fine, but presumably a free Lightstep account will work for you since you came here to one of our workshops. So that should take you to a link just so you can see what it looks like. And if you can just fill this out and say you're not a robot, that'll give you a free account. Okay, so if people wouldn't mind doing that in the background, or at least getting it done before we get to the walkthrough part, would be helpful. Alrighty, so getting started with OpenTelemetry. What is this all about? So we can actually start with the name. Why do we call it OpenTelemetry versus open tracing or something else? And the answer for that is that telemetry is really the correct word for describing the shape and boundaries of this system. So telemetry is the science or process of collecting information about objects that are far away and sending that information somewhere electronically to be analyzed. So telemetry comes from analyzing rockets and remote sensors and things like that. But with distributed computing and cloud computing, it's actually very similar. Everything is remote and needs to be remotely observed. And so OpenTelemetry provides that what we see as a standardization effort to get all software producing observability data in a way that is uniform and comprehensible, regardless of which programming language they're using or which programming environment they're in. We want to create a data structure that's essentially a graph of everything that's happening that can be analyzed by a system that doesn't have to know a lot of specifics about your software system. It just needs to know all of these standards and conventions. And that will improve observability quite a bit, or at least that's what we're thinking. So let's get into it. And again, just a reminder, there's a Q&A button. Please hit that and ask questions as I go through this. So let's just go over what the big pieces are in OpenTelemetry from an architectural standpoint. So the first piece you'll see, so this green circle is a service. And when you go to instrument a service, the first thing you have to do is install what we call the SDK. So the SDK represents the OpenTelemetry implementation in a particular language. That implementation is a framework. So it has a lot of configuration options. It has a lot of plugins and lifecycle hooks. When you can configure this to talk to a variety of different backends, and it's generally pretty flexible, like you imagine a framework would be. However, one thing I should note is that the SDK, you should only directly access the SDK when you're initializing your program and configuring it. Once the SDK is configured at startup, generally speaking, you should not be directly accessing the SDK, and you should never be accessing the SDK from application code or instrumentation code that isn't the code that's managing startup and shutdown of your system. And the reason for that is because the SDK contains a lot of these concrete specifics. And we want OpenTelemetry to be loosely coupled with your application. Observability is a cross-cutting concern, meaning that all of these instrumentation calls are going to be interleaved with the rest of your code. So the principle of loose coupling between systems is really important here. So to enable that loose coupling, OpenTelemetry provides an API layer that's actually separate from the SDK. The API layer, generally speaking, only contains interfaces, constants, things used for instrumentation and data standards. And it doesn't contain any actual concrete implementations. And the API is actually what your instrumentation code should be accessing, not the SDK. And so what this allows you to do is actually swap out that SDK. So not only is the SDK itself a pluggable framework, but you could completely remove it and swap it out with a different SDK. And that wouldn't change any of your instrumentation code. So an example of why you might do that is, say, a C++ implementation. Once OpenTelemetry C++ is ready, we'll be looking at seeing about the feasibility of binding for languages that can make foreign function calls into C++ as an effective solution for getting a performance boost. We could see about having an alternate Node.js implementation that was actually an SDK that just was making foreign function calls to the C++ implementation. So that's an example of how you could use the C++ implementation and get a performance boost, or you could use the native Node.js implementation, and then you've got the flexibility of a native framework, so you can write a lot of plugins in Node. So that's a core distinction. And you'll see this in all of our packages. You can see that they're divided into API and SDK. So the third piece that's really important with OpenTelemetry is the frameworks and libraries that you are using to manage your control flow and network connections. So not necessarily every framework or library you're using, but the core of your application usually involves some kind of control flow within the application that might just be a web framework that is doing a lot of the heavy lifting and has a lot of information about your app and is managing control flow like that. Or it might be a literal control flow, like some kind of userland scheduler, like something that was doing a lot of context switching. That is maybe a little less relevant in Node.js because it's single-threaded, but you will see context switching frameworks like, say, Akka actors, things like that, Python Tornado. Those really need to be instrumented. And Evan's asking, will the slides be available for review? Yes, I am totally happy to publish these slides. They're not public yet, but I will send a follow-up email to everyone who attended with a link to it. You'll also be getting a video of this, by the way, so you can watch that as well. So getting back to describing frameworks and libraries and why they're important. So you have some kind of framework that's usually, generally speaking, managing your control flow. It's critical that that be instrumented because OpenTelemetry depends on tracking your control flow. The other thing OpenTelemetry depends upon is riding along on your network requests, because we're trying to trace a distributed system. So anything making a network request, talking to another service, whether it's HTTP client, some kind of database client, a message queue, anything like that, it's important that those libraries be instrumented, not just so that you get observability data out of them, but they actually perform a function around propagating the indices that OpenTelemetry needs to work its magic. And we'll get into the details of what those indices are in a little bit. So that's why frameworks and libraries are really important, because they're going to be the things that actually get all of this instrumentation baked into them and use the APIs properly. And a bonus of being in this world of shared open source software, most of the frameworks and libraries people are using for these purposes tend to be shared libraries. People, generally speaking, aren't making their own HTTP clients. Like, some people are making their own frameworks, of course, but generally speaking, a lot of this code is shared, which means OpenTelemetry can provide instrumentation for all of this code. And in Node.js, because it's dynamic language, we can actually auto-load that instrumentation. So OpenTelemetry will actually kind of get in line with module loading and intercept it, and return wrapped or instrumented versions of any frameworks or libraries that it detects it has an instrumentation plugin for. Okay, so that's everything that's going on in your process. The next bit is, how do you get your data out of your process and what do you do with it? So the XDK has a plugin type called an exporter. The exporters are what manage sending the data to another service to be observed. And by default, OpenTelemetry comes with a collector exporter. The collector is another OpenTelemetry project. It's a standalone service, and it represents the sort of data pipeline part of telemetry. If you think of telemetry as generating the data and then sending the data, the SDK and API are generating the data, the collector is sending the data. So it's useful for pipelining, data massaging, things of that nature. It's working as a buffer to hold your spans in case your process dies. So by default, we have an exporter that will talk to that collector over OpenTelemetry's native protocol, which is called OTLP. Both the SDK exporters and the collector can be configured to use other protocols, though. So built-in protocols include things like Zipkin, Prometheus, Jaeger, hopefully StatsD and other things like that will be coming soon. So the collector is usually the place where you're doing that kind of data massaging, converting formats and stuff like that. I should note you don't have to use the collector. You can just use a Zipkin or Jaeger exporter directly into your SDK. So that's a common way. So I want to emphasize OpenTelemetry is a very well-factored project in the sense that if you choose to use one part of it, it's not automatically going to haul in all of the other parts. So you don't have to use the collector, but I do think the collector is a very useful pattern. Specifically because it allows you to keep what you're installing into your programs in terms of SDKs fairly standard. If those things are just assuming there's a collector, perhaps running as a sidecar, then they can have a default host import and other things that all of your services are rolled out with. And then you could run a collector as a sidecar and do all of your configuration through redeploying your collectors rather than redeploying your app in order to change a setting on an export, an exporter. So I think that's the real reason to use a collector as a sidecar, just for the fact that it moves the control plane for exporting your data and sending it out of something that would require you to reboot your app into something that an operator can do on their own without messing with the individual applications. So that's a big win in my opinion. You will notice that OpenTelemetry does not include any kind of analysis tool. So, you know, an analysis tool is something like Lightstep or the Zipkin backend or the Jaeger backend or, you know, Stackdriver backend. Anything that collects the data, stores it, and analyzes it is what we call an analysis tool. And OpenTelemetry does not come with one because we want this to be a standardization process, as I said before. And while it's totally feasible to standardize how programs describe their operations, it is not feasible to standardize how we analyze those operations. Analysis is the place where there's actually quite a bit of ingenuity and innovation going on right now. And my hope is that OpenTelemetry will actually foster a lot more of that. Simply because in the past, if you wanted to build one of these systems, not only did you have to build the analysis tool, but you had to build all this other stuff, including all of these plugins, which is a bit of a boiling the ocean endeavor. So I think personally, I feel like that is a barrier to entry. Certainly when I've tried to build these systems in the past and needed them to be decoupled, that was a barrier to entry. So the fact that anyone who has an interesting idea about how to analyze their operations and their program can simply write that analysis tool and then just point the OpenTelemetry fire hose at it. I'm really hoping that fosters a lot of innovation and that we're moving into a sort of observability golden era. That might be high hopes, but I really see a lot of signs that might be going that way. So how we keep track of all of this stuff realistically in the actual project, since we have all these implementations across all these different languages, is we have a specification. So a language neutral specification is sort of the core of OpenTelemetry. That's where we do all of the decision making related to the design and direction of the project. And then all of the maintainers of the various language are, of course, taking part in that specification process. And then they build out language-specific implementations. And this is what allows not only to have OpenTelemetry interoperate between languages, but to make sure the experience feels similar enough in these different programming languages that it feels like a coherent platform. Okay, so speaking of that, let's walk through the actual GitHub organization, because I think this is a useful place to start if you're wondering about how to get involved in the project. So let me do a walkthrough on that. But first, are there any questions about this general architecture and overview? This would be a good time to ask those. So anything about how the project is laid out, if you have questions, please put them in the Q&A. And if there are no questions, we'll just move on. Okay, well, you can ask questions later. So going through this GitHub org walkthrough. So if we go to GitHub, and we're going to go to OpenTelemetry. So this is, by the way, it's open-telemetry. Damn you people squatting this, damn you. Anyways, so open-telemetry on GitHub. And we have a set of pinned repositories up at the top. And these are really useful repositories regardless of which programming language you're using. So I do want to just point them out. A really important repo is community. The community repo is where we manage everything related to the OpenTelemetry organization. So if you're wondering how things are organized and how things work, this actually describes all of that. So it describes the project structure. We have a governance committee and a technical committee. Every working group is called a SIG, or special interest group, and they have maintainers and approvers and triagers. And this repo describes how all of that stuff works. It also includes links to where you can find us. So that's really helpful. So we are sadly on Gitter. I've told everyone that the reward for getting over GA is that we will move off of Gitter onto something else. But for now, we're on Gitter. And so you can find us there. And we hang out on Gitter a lot. So that is a good place to ask questions. And the other useful place to ask questions is at our live meetings. So we actually have a lot of meetings. Every special interest group meets every week. And we have a calendar that includes all of that. So this is just opening my calendar. We don't see that. So if we're just going to go back to all right, community. All right. So anyways, we do have a calendar. I recommend coming to those meetings if you want to have like catch a maintainer and just have a more involved conversation than you wanted to have on over Gitter. That's a good place to do it. And then anything serious about actually changing how the project works, we really insist all of that happens in GitHub issues. So we try to move things out of chat and into issues as soon as it starts looking like we're starting to make decisions about something. Likewise with the live meetings, we don't like to make final decisions on those meetings. We like to use those meetings to drive a GitHub issue so that other people can participate. We also have mailing lists. No one emails each other in this project, but these lists do exist. So the more useful ones are not the OpenTelemetry community because we tend to just use chat, but you can use this to message the technical committee or the governance committee or comms if you're interested in posting an OpenTelemetry blog post or something like that. So that's how the project actually works. And I'm mentioning this just because we're in beta, and I really think people who are trying this stuff at this time should get involved in the project. It's a great time to get involved. So moving on from the community, let's have a look at our specification. So this is the spec repo, and I recommend not reading the spec through from beginning to end because that will just put you to sleep. But there is a lot of really good information in here, especially right now when our API documentation is a bit scant because things are changing a lot and we're still in beta. The specification actually provides a lot of detailed explanation about what the intent of these various things are. So this is a useful place to look up terms. If you see a term, like I see a tracer provider in my code, what the heck is tracer provider supposed to do? The API docs might tell you how to invoke a tracer provider, but the spec will actually tell you like what the point of this thing is and how to use it. So I actually think using the spec as a reference for this purpose is useful. I personally use it like this occasionally when I come across something. The other really useful part of the spec are these semantic conventions. So what do we mean by semantic conventions? What we mean is describing the actual meaning of the data. So we have, for example, resource conventions. So these are all the various ways of describing your service, service name, service version. There are various like cloud-based systems. So if you're using Kubernetes, for example, these are all of the standard keys and values for describing your Kubernetes setup. And we have lots and lots of these, and we really want to get a semantic convention for every single kind of standard concept. So network protocols, all of this stuff. And that's one of the key things that lets backends process this data better than they could potentially process other data, because they don't just know the data format, they actually have some semantic understanding of the meaning of that data. So they can clearly see that something's an HTTP request or a gRPC request or something of that nature. So this is a part that I recommend having a glance at when you're going to production and thinking about trying to add a whole bunch of useful indices to let you track down issues. These semantic conventions are the way you do that. Okay. I think those are the two most important repos to talk about. There is also OTEPs. This is useful to know about. This is how we actually change how the project works. So if we're talking about a bigger, more meaningful change to the spec, rather than bake that directly into the spec, we have an RFC process. You're probably not going to make an RFC if you're just using the project, but I do want to let people know this is how the project actually works. So if you do want to get involved, like this is where the change actually happens. So anyone can make an OTEP. We have a template. There are many, so you can have a look at all the ones that have been made so far and how they work. Here's one I made recently about how to deal with error flagging and status codes. So that's actually how the project works. The rest of these repos, OpenTelemetry IO is the website. OpenTelemetry Proto is where OTLP lives. So if you're interested in the protocol definitions, they're there. And then, of course, anything that says JS is related to Node.js in the browser. And so we have two packages here. One is the core package, OpenTelemetry JS. And the other is the contrib package, which contains a number of other plugins. So if you look in OpenTelemetry JS and you scroll all the way down to plugins here, this will tell you where all of the plugins live. So there's a set of plugins that live in core and the rest of them live in contrib. So that's the layout of the project. Any questions about that? It's pretty standard GitHub stuff. So here's a question from Evan. Here's the $1 million question. Oh man, who gets the 1 million, me or you? When is the 1.0 GA release and API stability expected? Will it be the same date across all the languages? Yeah, that is $1 million question. If you could accurately peg when that was going to happen. So I don't want to. OpenTelemetry has a history of making deadline pronouncements and then blowing through them. So I am nervous at this point about making concrete announcements about when a GA is going to happen. But we are trying to roll this out in stages. We're actually going to release a blog post next week, I think next Wednesday, actually describing the remaining steps, so you will get a more concrete answer. But it will be sort of a gradual rollout. It won't be, there's like a 1.0 announcement and suddenly everything is 1.0 because all of these languages are in different states. So, and also all of the signals that we're collecting, whether it's traces or metrics or logs, those are all in different states. So the first thing that's going to GA will be the tracing specifications. The tracing portion of the specification will GA and be frozen. And then the tracing portion of various languages will start to GA. And metrics will GA soon after that. And then we'll maybe move on to more experimental things. But the two types of GAs you're going to want to look for is tracing has GA'd in your language of choice and metrics has GA'd in your language of choice. And if you really want to track this stuff, by the way, if you go up to OpenTelemetry, we do have projects up here. The GA spec burn down, this is where you can actually track our progress on getting the spec complete. So you'll notice we have a lot of tags, including a release required for GA tag. So that's a way, if you want to get in the weeds and figure out when this thing is going to get done, you can start tracking this stuff here. But as far as just like a great date, it will be GA'd on this date. We don't have one of those. My apologies. I don't know many open source projects that are capable of hitting a deadline like that, but we certainly are not. The project does have a huge head of steam going at this point, though. So, and we've tightened up project management quite a bit, as you can see here. So I do expect things to GA, if not by the end of this year, then certainly the Q1 of next year. You'll definitely be seeing GAs happen by then. The other reason why I don't want to make too many promises is my experience, especially with open source projects, is once you hit mid-November, like everyone disappears. But we're in a pandemic now, so maybe no one's doing that. Everyone's just hanging out at home and wants to work on some open source code. Okie dokie. So that's a good walkthrough. And Evan, thank you for the questions. Let's talk about some core concepts for OpenTelemetry. These are the things that you really have to understand in order for OpenTelemetry to make sense, because it's a little bit different from maybe traditional performance monitoring solutions you might have used. If you're already familiar with are on the same page. So, unstable internet connection. I hope you can all hear me. So let's do this. So we have a client, very typical. Let's say this client is a mobile app that lets you upload a photo along with a caption. Super complicated. So that client's going to talk to a server to upload that photo, but of course it's not one server. It's going to be a bunch of servers. So it'll be like a proxy server. Let's say that's Nginx or something, and then that's talking to an auth server to make sure you're authenticated. And once that works, then it's going to download your image to a local scratch disk. And then once it's done that, it's going to call your app. And then your app's going to grab that image and do whatever it does with it and upload it to cloud storage. And then once it's uploaded, your app's going to talk to your database and write down, where it put it. And so that's, say, a data service that's sitting in front of a Redis cache in a SQL database. I would say this app layout is beyond typical. I feel like I've been looking at service architectures like this for 20 years. And my experience is that with modern systems, they still more or less look like this, except they've just grown, right? They've just grown and grown and grown and grown. So you have a hajillion copies of each of these processes running at the same time. And you have many, many more services interacting with each other. But other than that, I really feel like the basic model hasn't really changed. And it was annoying to observe this stuff then, and it's annoying to observe this stuff now. So let's look at this from a call graph perspective. So this you can think of as a service diagram. But if you look at this service from a call graph perspective, you've got your green line here represents the client. The client takes the total amount of time in the transaction because the transaction is almost defined by the beginning and ending of the client's operation. In general, with OpenTelemetry, we're focused on these kinds of synchronous web transactions that occur within a sort of human time frame, like milliseconds to seconds response time. That's sort of the bread and butter with OpenTelemetry, though of course you can use it to observe asynchronous workflows and message queues and these other things. But it's really, the design is focused primarily on this common use case of synchronous web transactions. So the client talks to the proxy talks to the auth server, then it uploads the file, then talks to your app server, yada, yada, yada. So how is this useful? Well, one thing we want to look at when we're looking at this kind of graph is latency. We want to know where the time went in the program. So we want to know how long each operation took. But when you do a call graph like this, you can tell not just how long each operation took, but where it was doing work and where it was just waiting. And that's really important when you're trying to decrease latency. If you're trying to optimize your app, you have to optimize something that's actually going to move the needle on the overall time. And so figuring out what this critical path is an important part of distributed tracing. And so latency and control flow issues will jump out at you when you're looking at these kinds of graphs. For example, seeing that things are done sequentially when perhaps they could be done in parallel. That's pretty common. And looking for things that took a long time that maybe could take less time. So, here we're seeing a lot of time was spent uploading it to local scratch disk, and then the rest of the bulk of the time was spent uploading this to S3. And so what that implies is, hyper optimizing this data service, for example, that's not really going to move the needle, right? Like you could super duper optimize this service, and this is the most you're going to get out of that. The real time is actually uploading the files. And if you want to optimize this, that's where you're going to have to go. So you can see all of that just from learning to read these kind of call graphs. And these are very common. Almost any OpenTelemetry compliant system has some kind of display like this. The other thing we care about are errors. So where in this transaction did things actually go wrong? Was it the auth server that had a problem? Was it this cloud provider that was having the problem? Was it our data service that was having a problem? Being able to quickly root cause things is really important. And this is one of the things OpenTelemetry helps with a lot, because you get so much context with your events and errors, it can tell you quite a bit about what was actually happening and where the problem was. In my opinion, it does this better than other systems that we've used in the past. And then, of course, the third thing you're looking at is the actual call stack of all the events. And we call these events in OpenTelemetry, but really they're basically logs. Like when you add events to your spans, these are basically log events, and you can actually connect OpenTelemetry up to your logging library, potentially either to turn your logs into events and get them into your traces, or to go the other way and get some of these useful tracing attributes attached to the logs that you're generating for some logging system that you don't want to give up. So following these events is like the third crucial part of what OpenTelemetry is good for. And then, of course, correlating all of this stuff. It's one thing to look at this data as a single trace full of events. It's another thing to look at all of these traces in aggregate and start to identify places where you're seeing a correlation between, say, an error occurring in a particular region or host or URL. That kind of correlating is really the core of why distributed tracing and OpenTelemetry exists. This is the stuff that I found really hellish back in the day. When you have a distributed system like this, how do you actually generate this call graph of events if all you have are logs? You have to go do a sort of ad hoc search query to get all of these logs, because you're not going to have one identifier that's available on every log to do a query to find all the logs that were just in this transaction. If you did have one of those, it would be something like a transaction ID, right? Like, let's say you have 128-bit ID that is attached to every single event in your system and gets propagated along to each new process. And so they can all staple that same ID onto all of their events. And then you can look up all of these events by that transactional ID. So we call that transactional ID the trace ID. And that's probably the most useful thing you'll get out of distributed tracing. Though obviously you want to correlate across all these other indices as well. But solving this issue of going from having all of these logs to filtering down to just the logs that are relevant, OpenTelemetry really provides in this area. This is, I think, the place where it's better than non-tracing based systems, because you're actually propagating these indices. So let's get into that. Context propagation. This is the core concept in OpenTelemetry, and if you can understand this, then the rest of the project makes sense. And that's just, you're looking at, say, two servers, A and B, and you have some operations, and they're connected by a network call. The context part of this is tracking these operations within your program. So the context object is basically a bag of key value pairs that is always available to your transaction and follows the flow of execution. When you get to a network call, though, obviously this in-process context bag can't go over the network on its own. It has to get serialized. And so that process of serializing this context and adding it as metadata to your network request, that is called propagation. So the context part is in process. The propagation part is between processes. And the act of adding all of this context to your request, in HTTP, these get added as HTTP headers. We call that inject. So you're injecting the context into your carrier, is the language we use for that, and then propagating the context to the next service, where you extract the context and generate a new in-process context object to continue following the flow of execution. And so this core structure is what allows you to have access to these indices and key value pairs across your entire transaction. And if you don't have this form of propagation, then you can't do that. You'll have a request ID, but then what about the hop from service B to service C? That's going to have a different request ID. And if you try to manually set up this kind of propagation, that is just a huge amount of work. So the fact that OpenTelemetry will just auto install a bunch of plugins that does this for you, that's the biggest time saver that OpenTelemetry can give you. And in addition to trying to standardize stuff within OpenTelemetry, we're also trying to standardize these headers. So the W3C is the standards body for HTTP, and myself and a number of other people, most of them who also work on OpenTelemetry, have been working in the W3C to actually get standardized headers for all of this tracing information so that we can get better interoperation. So one set of headers that are well on their way are called trace context. That consists of 2 headers, trace parent and trace state. You don't really have to worry about trace state. That's internal stuff for tracers. Trace parent is super useful though. This contains the trace ID, which is that transaction ID I was talking about. And it contains a span ID that represents the parent operation. So you have 2 IDs always available to you at minimum. The overall transaction, so all the events in your transaction, and then all the events within your operation. So that's the basics of OpenTelemetry right there. In addition to these core headers and core key values, we also have a concept called baggage. And the baggage header is literally arbitrary key value pairs. That's all it is. And this is what allows you to send additional indices besides these core indices. For example, let's say you want to index some operations by project ID. In order to do that, you need to get that project ID. And maybe one service early on, let's say the client, gets access to that project ID, but other services down the line may have trouble accessing that, or it might be expensive if you do an extra database call. You don't really want to be doing those things just to get some information for correlating your correlating your observations. So what you can do is set a piece of baggage called project ID with a value 1, 2, 3, and that will get propagated along. And then any service down the line can just pull that project ID value out of the baggage. So that's the way you send these sort of distributed indices around your system. I should note there's overhead here, especially with baggage, because it's arbitrary key value pairs. If you are really aggressive with this and make lots and lots and lots of correlations that have big, heavy values, then you're going to bloat your network requests, right? Your payload size is just going to get bigger and bigger. So you do have to manage baggage from that perspective. You do need to be a little selective to the degree to which payload size is an issue for your system. So that's one gotcha to note about. Okay. And these SDK slides, these are kind of whatever. So let's actually pause at this point and see if there are some other questions. This is sort of the end of like the basic overview of the structure of the project. So if you have structure related questions, this is a good time to ask them. Oh, and I did go wonky for a minute. I'm sorry about that. So Evan asks, is a typical use case for baggage something like propagating a locale through the system? Yes, this is exactly like what it's for. You know, you have something that is easy to access at the beginning and is super important. But, you know, how is your data server 3 layers deep gonna know about the locale, right? Like that's something the browser knows about, but not your data server, and your data server can't even look it up. So that's a great use case for baggage. Absolutely. Cool beans. You see my screen? Pretty sure I'm sharing now. Okay, so let's look over some best practices while we're waiting for Matt. So one question people want to know is, how big should a span be? So a span is an operation, and you will find when you start instrumenting your own code that you'll have this question of like how many spans you should make. Should every function be its own span? The primary use for spans is or two things. Spans have two uses. One use is they hold all of the indices that you would like to have applied to all of the events in that operation. So rather than staple locale onto every single event, you add locale as an attribute to that span, and then every event that occurs within that span can be looked up with that attribute. The other use case is measuring latency. Spans have a start point and an end point, and they record how long that span took. So that affects where you might actually want to put this. How granular should these things be? And so there's like a couple levels of granularity that you think about in OpenTelemetry, right? There's a whole transaction. We've been talking about that. There's the process. We've been talking about that. There's a library, right? So every time your code base goes through a transition from one library to another library, that's an important scope or transition. Which GitHub repo should I look in order to solve this problem is something really important. And then at the bottom, you have a function scope. Everyone knows what this is. So like, where do spans fit into this? And the answer is like, they fit in somewhere kind of between library scope and functional scope. You probably don't necessarily want one span per library, though that is like a good way to get started. But a span for every single function is going to create trouble for you. One thing is like, it's going to be expensive. Spans cost more to make than logs. So if you're really heavily creating lots and lots of spans and heavily measuring time in your system, that will actually add overhead to your system eventually. So there is some small cost associated with them. Starting and finishing spans can sometimes involve juggling scopes and context. So we'll see this in our walkthrough, but often OpenTelemetry needs to create closures in order to make these spans and everything available to you. And I find that can make your code a little ugly. So you don't want to be just littering all of your application code with lots and lots of spans necessarily. And you really don't need to. And in fact, it's better to have fewer spans in the sense that most backends today can't search for attributes across multiple spans. So if you're trying to say, foo, I want to see traces where foo equals bar and, baz equals lerman. And if foo and baz are attributes on two different spans, that analysis tool may not be able to look that up. I imagine things like this will change in the future, but that's just sort of a practical reality of where a lot of systems are today. So because of that, my recommendation is you should have fewer spans that are more coarsely grained. Basically, I recommend having as few spans as you can get away with while still getting the latency and operation information that you want. Obviously, if you don't have enough spans, it's hard to tell where the time went. But as few spans as you can get away with clusters all of your tags together. That improves search. It's cheaper to do. And it'll potentially help you find a way to sort of centralize the management of these span creation, which can help your application developers. So this is just a repeat of what I just said. And this is a repeat of what I just said. I'm going to delete these slides. Burp. Gone. Okay. So do we have any questions around this practical advice of creating spans? I'm not quite sure where people are at. So maybe you don't even know what a span is. That would actually be helpful if I'm using lingo that you don't understand. So Evan asks, without much experience in analyzing traces, it seems that rather than making internal spans, it's sometimes good a good alternative to just create an event at the start end of the process of the existing span. Yes, that's absolutely true. There's no reason why you can't just create events and then you can look at the time between those events in order to get a sense of, where time went, the same way you do with logs. So yes, you don't necessarily need a lot of internal spans. For me, the way I think about it is, if I saw a lot of latency in this span, would that be enough for me to actually track down that problem? Or would I still be asking, okay, I see all this latency, but is that coming from library A or library B or library C? I can't tell. That would be a sign that maybe you need a span for library A, B, and C, as well as the wrapping span for the whole thing. But yes, in general, OpenTelemetry comes with instrumentation out of the box, and that should be good enough to get started. You shouldn't actually have to write instrumentation by hand in your code very much if the auto instrumentation has actually found plugins for all of your frameworks and libraries. Cool beans. Oh, cool. And it looks like we've got Matt on the call as well. Can we both talk at the same time? Is that possible? Matt, you want to say hi?
Howdy.
Hey, hey, hey. So Matt, I already introduced you a little bit as one of the co-maintainers of Ruby. And I forget, are you a maintainer on the JS side or just a contributor?
I'm an approver and contributor, not maintainer.
Awesome. So you've been hacking on some walkthrough stuff, is that correct?
Yeah. Should I show a walkthrough?
Yeah, do you want to lead that up? Just so people know, this was some code I started with and Matt graciously has helped finish. So yeah, if you let me stop sharing my screen, and if you want to share the screen, you can take it away.
Cool. I'm getting some windows arranged. All right. So yeah, this is some code that Ted started with earlier, and I'm not sure if you all have a link to this repo, but this is where it all comes from, and this is where you can find it. It's a simple client and server app, and yeah, I guess I can kind of walk you through first the code, and then kind of show you how to set up OpenTelemetry for an application such as this, and then just kind of how to interact with some of the spans that are being created there.
Yeah, Matt, do you want to start with the setup?
Yeah.
Because ideally, people shouldn't have to write code, right? In the sense of, we see get current span and set attribute and stuff here, but to actually get started, you should be able to do that without writing any of that code.
Yeah. So so ultimately, you all probably have some apps today that you're very interested in getting off, up and running with OpenTelemetry. And this kind of boils down to setting up an OpenTelemetry SDK. And since OpenTelemetry itself is like pretty flexible and doesn't have like a ton of opinions like out of the box, like that setup can be, there are a lot of options to kind of work through there. So for Lightstep, we kind of have opinions about a lot of those options, and those opinions are the ones that are going to work well with our tracing backends. And our satellites are actually, they ingest OTLP natively. So we're able to kind of use purely OpenTelemetry for this purposes, but we kind of created these packages that we're calling launchers, and they kind of bring these opinions of how to set things up and are able to kind of streamline the setup pretty easily. But it's really just like a really thin wrapper around things that are already here in OTel.
Yeah.
So
if you don't mind me jumping in here, this is actually a concept I'm pushing in OpenTelemetry. We're calling it distros, OpenTelemetry distros, which is every backend that wants to connect to OpenTelemetry, often will need maybe some kind of plugin installed, like a sampling plugin or an exporter, or like Lightstep. We want to set a gRPC header. The actual configuration to configure all these things is a little messy because it's so flexible. But it's easy enough to package all of that up if you have a set of opinions already that you want to use, like Matt was saying. So that's what this is. And just to be clear, this is pure OpenTelemetry. It's completely compatible with any other OpenTelemetry options you might want to set.
Yeah. And feel free to chime in on any of these things to add color. But yeah, so this file here is purely set up, and your code is all here in this client for the client portion of this application. And if you want to look at the client, it's something that makes 60 requests to a backend, but yeah, I think I don't have too much else to say about this. I will mention just a little bit about why you require client inside of a callback, because this is something that is a little weird, I think, for a lot of people. And this is something that will probably likely change in OpenTelemetry JavaScript. There are reasons, and the reason is there is a notion of resources in OpenTelemetry, and resource is their attributes that kind of pertain to the process, more or less. So this is like, is it running in a container? Is it running in AWS? Is it running in GCP? If so, like what is the instance type? What is the instance ID? Like all of the stuff that you need to identify your deployment. And there are resource detectors available. So there's these, there are detectors for like AWS EC2, GCP currently. And the way that these work is that they contact, and first you need to require them and use them. But after that, they make a request to some internal endpoint. And if that internal endpoint responds, then it goes ahead and processes the information. It's usually a JSON document or something similar. And it will automatically kind of attach these things to your spans. The TLDR is that this is an async process, and for that reason, you need to wait for these resources to resolve before you can start the SDK, because these end up getting added to each span. At least that's the current architecture. It would be ideal if this were a more synchronous startup and things could look a little more natural, and it's something that we're looking into, but it's not, immediately something we can do without like a little bit of re-architecture.
But just to emphasize why this layout is handy. So basically, like what Matt is saying is, you want to load all your requires synchronously and have normal startup, but at the same time, you need to potentially asynchronously wait for OpenTelemetry to do some stuff. So that's tricky. And the way to resolve it right now is to basically whatever your entry point is to your app. So if you were normally calling Node client.js to run this client, you would add this file called trace client. And you'll note that all it does is set up OpenTelemetry. And then when a promise resolves after the SDK starts, that's when you require your original entry point. So this lets you do a bit of asynchronous work at the beginning, but still kind of load your program as normal, because when it does get loaded by calling that require, everything from that point, all of your other requires will be synchronous and normal. So it's slightly weird, but if you just put this stuff into another file like this, then you don't necessarily have to muck about with your existing application.
Yeah, and this is something where like improvements are afoot, I guess. So expect this to get better if it's a little weird today.
Yeah.
And then this is kind of the server, the raw server file that will end up requiring, and kind of the similar instrumented server, which has kind of the same setup that we were just seeing in the client. The server is a little bit more interesting, I think, because we do start interacting with OpenTelemetry here. And you'll see that for this root route, there's auto instrumentation, and auto instrumentation will kind of start a span for this. Since the flow of data will be from this client to the server, we actually kind of have a very small distributed trace, and it will link up the spans from the client to the server. And even though we haven't created a span, we are able to kind of like pull the current span out of the ether here. This is the current span that's created by the instrumentation, and then we can interact with it. We can set some attributes, we can add some events. And I probably should have done this to start this whole walkthrough, but we can actually look at what this looks like. So
would you mind showing people how to find their access token while you're doing that? Because that's an important step.
Yes. So don't look at this trace. I'm going to show you how to find your access token. So if you're logged in, you probably see something like this in the Lightstep backend, I hope. And this would be your home. If you come to this gear icon, this is where you will find an access token.
Great. And so you have to take that access token and add it to anytime you're starting OpenTelemetry for connecting it to Lightstep. And the launchers make this easy because we just have an access token flag.
Yeah, and I guess I kind of glossed over this whole setting up the launcher step. So maybe we can look at that in a little bit more detail. So right here, there's a couple properties that you can provide. The only one that's actually required is a service name, but most likely you're going to want an access token. There are some satellite configurations for Lightstep that allow you to not have this, but for the most part, if you're sending to the Lightstep SaaS, you will need an access token. Lightstep launchers, like we kind of alluded to before, there's a lot of options for OpenTelemetry, and propagators are one of the things that you'll have many different options for. So this is kind of the context format that is going to be on the wire for your distributed system. OpenTelemetry has support for W3C trace context and correlation context. That's actually been renamed to baggage, but that was pretty recent. But it also has support for other formats. B3, Jaeger are other ones, and it's an extensible API. So if you have custom formats, you can set up custom propagators.
I should hop in and say, this is actually a gotcha, especially if you're trying to migrate to an existing system. But one of the gotchas is having your propagators misconfigured. So one service is sending B3 headers and the other service is expecting trace context headers. That's a pretty common problem, and it can be a little pernicious to see because your traces just won't be propagating, but that's always a thing to check. If you see your traces are going fine and then they're just not propagating to the next server, one thing to check is whether or not those two systems are configured to use the same propagators.
Yeah, so for the launcher, we use B3 by default, and the reason is there's a lot of existing stuff out there using B3. It works well in kind of our ecosystem, and I think it will probably work well for a lot of people who are migrating to these newer standards. The W3C standard is the one that we expect everybody's going to be using in the near term, but I think there is kind of like a migration path there. So here we're having to explicitly set this up for W3C, but out of the box we're using B3.
Yeah. So that's a thing for you all to consider if you are interacting with existing systems. Oh, and by the way, B3 is the Zipkin tracing headers. So this is sort of a de facto standard that was around, but was not part of the W3C. So if you already have stuff set up that's using B3, then this works out of the box. If you want to future-proof your system, you may want to consider switching that to trace context as the default. Just because if you're not doing this backwards compatible stuff, you want to be future compatible, and the trace context stuff will probably be more future compatible than the B3 stuff. Or that's my take on it. Matt, you might have a different take.
I have that same take. Like if you have no existing stuff, just go with trace context and W3C. If you have existing stuff, it's going to kind of mandate what you do here. But migrating is going to be the best kind of near term strategy if you're not already there. So yeah, and we similarly glossed over the client, but it looks like identical. Like I almost can't even tell that they've changed. Yeah. So the changes, if you notice, are just kind of the service name and the require that we have here.
Yeah. Yeah, I think if y'all want to use this GitHub repo, you could just copy paste this file as a starting point. Because all you're doing is requiring your original entry point to your app. Like this is pretty much boilerplate.
Yeah, and we could probably talk about this a lot more. I will say that as far as these options go, all of these are also settable by environment variable, I think. Yeah, for people who are interested. Like usually in-code configuration is not what you want to do in the real world, but it is, the way you will probably set up small examples such as this.
Yeah, and if you look at the Node launcher README, it contains all of those environment variables, or at least the ones we think are important. I don't know if Node.js has added new environment variables.
Yeah, I think this is an ongoing thing. Like in OpenTelemetry, it often happens that all the different projects are working on similar things at the same time, but not always at exactly the same time. And as we're building things, we realize, hey, there should be configuration for this, and then hopefully that trickles up to kind of the specification level and kind of gets surfaced there, and then all of the different languages kind of follow suit. But there is kind of like this process of discovering that you need this useful thing, kind of announcing it to the community and just kind of getting buy-in that, yeah, this is actually a good idea, and then having it kind of trickle down and get implemented in each language. So
which is that was what I was mentioning before actually about the spec. So if you do have an issue, you're like, oh, I wish I had an environment variable, or I wish OpenTelemetry worked a certain way, you could post that issue on the Node repo. But if it seems like a cross-language issue, like environment variables, then the spec repo would be where you would post that issue.
Yeah, and specifically for things like launcher, like sometimes stuff makes it into the spec long before it, there's sometimes a little bit of lag between when things make it into the spec and when things make it into OpenTelemetry, JavaScript, for example. So we've kind of tried our best to like get ahead of the curve. So sometimes we'll kind of implement or we'll
Prototypes, essentially?
Well, we'll interpret environment variables that don't yet exist in OpenTelemetry.js. For example, things that are coming, and then when they actually are shipped in OpenTelemetry.js, we just kind of remove them from our launcher. But it's kind of a way to, and this is really to help people who are working in multiple languages and are like, I have this environment variable in, in Java or .NET, but I don't have it here. And it's just kind of confusing because you often want to use kind of similar setups between your apps. So that's kind of been like another good use of these launchers, is to kind of bridge those differences while the individual language sakes kind of catch up on everything. But soon things will have GA'd, and I think there should be things should be standardly implemented between all the different language segs. But I think in the road up to GA, everybody is at like a little bit different level of completeness.
Yeah. Okay, let's maybe look at some traces, huh?
Yeah, let's do that. So the next thing that you're probably going to want to do is just start these things up. Yeah, I think we kind of went over this. We have our instrumented server in one file, but then we kind of set up launcher in this trace server, and so nobody has to get their microscope or magnifying glass out. That might look a little better.
Yeah, could you bump it up a little bit more, actually? There, that's great.
Yeah, so I'm just going to launch this, Node trace server JS. So there's not actually a whole lot to see. You can see that the plugin loader for JS has realized that we are using the HTTP library as well as Express. So it's mentioning that's installing this instrumentation for us, and the server is up and running. In our other window, this is where we're going to run our client. And similarly, we have this trace client. If anybody remembers back to when I was rambling about that, it makes, I think, like 60 requests. So, so if we run that, we will see these 60 requests. And those will end up creating spans. Those spans will end up at Lightstep. And there are a variety of ways you can get it in and see this, but yeah, these are some spans in our backend. If you click any of them, it will assemble all of the spans for this trace, and this is what it looks like. So
yeah,
these. Go ahead, Ted.
Oh yeah, I was just going to mention the attributes you can see for the span, everything that was automatically instrumented is very rich with data. So you can see all of those standard conventions. So you can see HTTP flavor, host, method, route. So all of this is automatically added.
Yeah. So if we walk you through this a little bit, I don't know if Ted has demoed any traces yet, or if you're used to seeing them in Lightstep. But this initial span originates in the client, as does this second span. But here is where the request makes it to the server, and this is kind of this is like the important part of, this is a very important part in a trace. This is kind of where the context propagation has occurred. And this is kind of the gotcha point where if you have not set up your propagators properly, or if they're different between the client and server, you will often find that your traces kind of break at this boundary right here. So if that did happen, you would see like two tiny traces, one for just like the client and then one for the server. But because we've done things properly, you have both of them here. And, you know, in the real world, your traces will be a lot more complex and probably span many more systems, but kind of.
But that actually is a good rule of thumb. If you're seeing broken traces, but you do see that you are getting the portions of the traces from all the different services, that implies context propagation is your problem. If you're just seeing traces from some services and no traces from the other services, that's probably not context propagation. That's probably some other issue.
Yeah, exactly. Some problems you could be having would be just having your exporter misconfigured, or you could, another big problem if you're not seeing anything at all from a service is that like auto instrumentation might not have gotten installed properly. There are some like, there are some situations where that can break. It usually has to do with setup. But yeah, and to kind of continue what Ted was saying, like each one of these spans, if you kind of look over here, you see all of the rich attributes that have been added. And a lot of this, most of this has come from the auto instrumentation. And as you click on different spans, you get different, different attributes depending on what created the span, what type of span it is.
Yeah. Actually, getting into the actual instrumentation, when you get to it, Matt, would you mind showing how to record an exception and set a span to an error? Because I think that's a critical thing people should learn.
Sure. So I guess one other thing I was going to mention while we are here is that here we're on our server span, and most of these attributes like are pretty useful. One that sticks out as being kind of suspicious is this foobar key value pair, not super useful. It's here because we actually added it. So if we look at our instrumented server, you'll see that I kind of mentioned this, that you're able to kind of like grab this auto instrumentation span, the span that was created by this is the express instrumentation right here. And yeah, so you're able to kind of just grab that span out of thin air with tracer get current span. One gotcha is there's no guarantee that there's a current span. This can be turned undefined, so be careful when using it. But we've set a custom attribute here, and this is something that that you will probably find yourself doing a lot, trying to kind of augment what's already there with the auto instrumentation. So sometimes you'll just want to grab the current span and add something to it, such as an attribute or an event. We're kind of doing both here. Or you may, depending on the situation, want to create your own span. It depends.
Yeah. And so like the basic pattern, if you want to replace your logging with tracing, then it's, yeah, this pattern of like every log line is essentially get current span dot add event. That's the OpenTelemetry equivalent of log, essentially.
So yeah, we should see an event here. Yeah, and we do see this event down here. I think my browser could be better size for the share.
Yeah, I really want to improve that display in Lightstep, side note.
Yeah, I feel like we could have like a little bit of buffer at the bottom of the screen there.
Yeah, I want to show logs off better. Oh, one thing to note here while we're looking at this is instrumentation name and instrumentation version. So this tells you where this span came from. So where you see it says instrumentation name and it's showing you this package OpenTelemetry plugin HTTP, that's super useful. That's telling you, if you're like, where the heck did this span come from? That's a good indicator of where it was generated, and that can tell you some useful information. And actually, when you create a tracer, you have to name it, and that naming process is what gets generated in here. So I think if you look at another span that we generated, it should say server there, because that's what we named our instrumentation. So I don't know if you want to click on one of those guys.
One of these.
Yeah, if we're, actually we're not creating, yeah, one of those subspans we're creating. Or are those all being created by, those are all being created by Express. Yeah, my bad. But
Yeah.
if we were to create our own span, it would be called server. Maybe that's the thing we should look at next.
So yeah, if you wanted to look at creating a span.
Yeah, why not? That's a pretty core thing. Like, how would we create a new span, set it as active?
Yeah, so we can go ahead and do that. So yeah, like I mentioned, there are some situations where you may end up creating your own span. I would say the need to do this actually drops off significantly as instrumentation, as there is more and more auto instrumentation and things get better. But for sake of demo purposes and just general knowledge, like this is something that we can do. So we can create kind of an inner span in this HTTP route. We can just call this inner span. So the first thing we need in order to be able to create a span is a tracer, which we've already initialized here on line 7. And this is where Ted was just kind of mentioning, we get a named tracer. So we're naming our tracer server, so that instrumentation library and version that we're saying, this is where this comes from. Version is optional, but if you wanted to, you could pass a version here. So we do that for fun. And to start a span, there's a start span method. And the only thing that's required is a name. So right now, start span will pick up kind of whatever the currently active span is in this context. And that will be the value of get current span. And I did mention that that is not always guaranteed to be set. So I think that's one thing to keep in mind. So sometimes you do need to do some finagling to either manually specify a parent, and you can do that by manually passing in a parent. So like you could do that if you had to, but in this case you don't. So yeah, we will get rid of that.
To clarify, yeah, the current span is automatically set as the parent if it exists.
Yeah, and there's this other thing that you can do. Like if you have like some code that if you have a chunk of code that you want to run and have the same parent present, there is this notion of something called withspan. And again, we don't have to do this because this is already the case, but you can use this withspan method and kind of pass a closure in here and have like mini lines where that current span is.
Yeah, actually, do you mind showing how to set up the inner span as a current span in there? Like how does that work, right? Like if you did with span with inner span, where would get current span return that inner span?
Yeah, so I guess we can do that. So like I said, that will make inner span kind of the current span. So yeah, if we did this again, then current span will be the inner span, and if we did something like this would set an attribute on our inner span. Like all of this is completely contrived and really not super useful in terms of what we're actually creating with the span here, but it does kind of demonstrate.
Yeah. Do you have to end that span, or does with span end it for you?
You need to end the span at some point. So
yeah, that's another gotcha.
Yeah, it's a huge gotcha, and it's actually a big problem if you don't end a span because they kind of hang out in memory.
Yeah, that's the one place where you could get a memory leak from OpenTelemetry. I mean, I guess you could have an accidental memory leak somewhere else, but as far as the design, the only really stateful thing you interact with where you have to manage its state is the span, because it has a start and an end, and it's not closure. So that is a gotcha. You gotta watch out for that. And by the way, Matt mentioned like this is contrived. I think the best way to learn what real instrumentation looks like is to look at and that'll give you some that'll give you an idea of how to really write this stuff. And I think I just blipped out there for a second, so apologies.
Yeah, I'm just pretending I heard something during that.
Yeah, sorry, I was just saying that a good way to, if you want to, Matt just mentioned this is contrived. If you want to look at writing an instrumentation plugin, which is really the best way if you're writing like span level stuff, you probably want to do that, you know, as a plugin or something, not just directly in your application code. But if you look at those plugins that exist today, that give you a sense of like how to actually build an instrumentation plugin and manage spans.
Yeah, and those, I would say a lot of those plugins, those are kind of like the master class, but like, you know, they are really educational to look at. They're probably, a lot of them are things that you know, you might want to clear an hour or two off your afternoon and get a coffee and kind of go over those things because they do have a little bit more to them. Generally, like the thing that kind of takes all this, I guess, to the next level is there's usually some monkey patching and other things going on at very specific points in time. So So that would be kind of like the new stuff that you're probably not going to do to your app directly that you'll find in the instrumentation plugins. But as far as all of the, start span, with span, set attribute, set event, or add event, all of that should be pretty clear and straightforward from looking at those plugins.
Yeah, it is contrived, but I do feel like this example, like line 13 through 22, that is just the core of OpenTelemetry tracing right there. You don't really need much else other than that to write application code. There are things like propagators and stuff if you're writing instrumentation code that does inject and extract. But as an application developer, you don't really need to know about that. Again, you could look at existing plugins if you want to get a sense of how to write those things.
Yeah, I mean, contrived is not necessarily terrible. This is actually like a good, simple way to kind of illustrate this without without tons of confusing code. And I feel like that's what you will probably see in the plugins. But I think you should still look at them.
Yeah.
But there's going to be a little bit more to digest there. So like there will, I guess just keep that in mind. But do it. Look at this and look at the plugins. It will be good for you.
And I think that's a good stopping point. So we're actually 10 minutes into our break. So we're going to take a 20-minute break. But I would recommend, you can grab this repo. I'll include it again in the chat, just in case people don't have it. Repo. But use your break to take a break. But if you want to ask questions about this walkthrough and play with it, please use the Q&A during the break to queue up those questions, and we'll answer them when we come back from the break. Hello, everyone, and we are back from break. I hope you all had a good break yourself. Waiting for any stragglers to come back. Does anyone have any questions at this time about the walkthrough that we just went through with Matt? Or any OpenTelemetry questions in general? We're going to move on to how do you roll this out as an organization. So if you have questions about the API or stuff related to the code level, it'd be good to have a talk about that right now. Cool. Doesn't seem like there's, there's a question. I should wait longer because people have to type these things. I'm used to people asking questions. No more questions. I need to run. Oh, Evan's leaving. Yeah. Goodbye. Actually, Evan, let me give you a link to the slides before you go, because I did just make these public. So there's the slides. Hopefully I caught you. Great. All right. Well, thanks, Evan. Really appreciate the questions. Okay. So let's get back into it. So for this bit right here, we're going to talk about how you actually roll this out. So we've looked at the basics of like how you set OpenTelemetry up. How do you actually roll it out? One thing that we've seen is, when you try to roll this stuff out, there's various ways things can go wrong. It's a little bit of effort, and you have to roll things out kind of across the board. So one thing that's important is to just get a clear understanding of why you're installing OpenTelemetry and get a clear understanding of like what kinds of problems in your system you're trying to solve, like what's currently not working for you with your current observability system. What goals do you think you're going to get? It's just important to have goals when you start an endeavor like this. And it's important to recognize that the bulk of the code and the effort is going to be around instrumentation, not necessarily having to write your own, though, because as we mentioned, OpenTelemetry is still in beta, so there may not be instrumentation available for a package that you're using. But that is just the vast bulk of where the code ends up being. So the degree to which you're having to manage code with OpenTelemetry, it's going to be instrumentation code. So how I recommend getting started, if you have a centralized ops team, or like an infrastructure team or a platform team, or any form of centralization in ops and deployment where OpenTelemetry could be added to every service, or if your services have some kind of common setup somewhere, that's ideal. It's ideal to just get OpenTelemetry deployed everywhere all at once, because tracing works much better when all of the services have tracing installed. But that may not be realistic if you have a lot of services and a number of engineering teams, and there isn't a way to centralize this. You just have to add tracing to every service and redeploy it. Then I really recommend this approach of trying to pick a target rather than let's add tracing everywhere, because that's a bit like boiling the ocean. Figure out a specific important transaction. It could just be a really important transaction, like payment transaction, or it could be an issue where you already have a known latency issue and it's just a thing you'd like to get to the bottom of. That's really an important thing to have in mind when you start, and then try to get an end-to-end trace covering that particular transaction. So hopefully by picking a high value target and only instrumenting enough to get that end-to-end trace, maybe limits the scope of the initial engagement, so that you're not having to get it everywhere if that's a problem. And as we were mentioning before, you don't necessarily even need to write a lot of application level instrumentation code. Just getting the framework plugins installed and getting context propagation working and getting that high level view, that's the most important thing. Getting that high level end-to-end trace on something you care about. And once you've got that first trace, you now have something concrete to talk about with other people and to show them, and then you can expand from there. Expansion might mean adding more and more detail to your actual application. As you get a sense of how you're actually trying to observe this stuff, like what kind of monitoring you're doing, you can start adding more meaningful tags and attributes. And then, of course, adding it to services that don't have it yet. I jokingly call this a blame-driven development sometimes, because what we see is, one team will implement distributed tracing, and then to figure out where their latency issues are, and then they're able to track it down to a service that's downstream from them and that doesn't have instrumentation, and then they can go to that service and say, hey, we're seeing all of these latency or issues, and it appears to be coming from your service. Could we instrument your service? And then they'll want to get to the bottom of that. So then they instrument it and figure out where the problem is, or realize it's maybe a service they're depending on, and so on and so forth. So I do joke when I say that's blame-driven development, but that is like a good way to add services, is just continuing to pick issues or high-value targets and using that to drive adding more services into tracing, just so there's a reason to do it and a goal. And I mention all this because there are common pitfalls. It's possible to try to roll out OpenTelemetry or distributed tracing in general and have it not work. This is definitely a thing I've seen. Is someone, perhaps one of you on this call, is like really interested in distributed tracing. You're thinking about championing this issue at your company. You really care about observability. But it might be hard to do if what you have to do is just kind of get ad hoc buy-in by going around to various groups and saying, please add this. And what that tends to result in is, you know, kind of like a spotty rollout. So that, you know, whether or not you have complete traces, whether or not the value in those traces is high, is probably going to be questionable unless you put some effort into ensuring that the rollout is coherent. Because if you're looking at traces that are just like a single trace line for like a single service, with that doesn't look very compelling to people. So if the data quality is low, then it's hard to get people to see the value of tracing. But if you can get a real proper end-to-end trace, then the value usually leaps out at people and they understand why it would be useful for them to add it to their service. So that's really it. Basically, if you are going to roll out distributed tracing, it's important to recognize this is probably an engineering-wide project. You know, you're going to eventually need to get all of the service teams involved. So some amount of project management is going to help make this work. If you're an engineer, partnering with a manager who can help with this form of project management is, I think, super important. And that's again because you're probably not going to be able to add distributed tracing everywhere yourself, unless this stuff is totally centralized, in which case, great. And the more you can kind of centralize around observability in your organization, I think the better it's going to work, because we're not talking about observing individual services anymore. We're talking about observing entire transactions and observing how everything is operating together. So that's another reason why centralizing some of the resources around observability, I think, is an important kind of DevOps practice. Standardizing, you know, naming conventions, adding like helper libraries to make, you know, common things you're doing easier to do. Like that's anything you can do to make observability easier and more understandable to developers who maybe, you know, they're used to testing, but maybe not super used to observing systems. Certainly in the past, I've seen this with logs, right? Like how well instrumented with logs services often comes down to like the individual developer that happened to be working on that piece of code, because it's hard to standardize logging practices, but it is an important thing to do. I think it becomes more important with distributed tracing. I should also mention, we're trying a new thing at Lightstep. So I was asked to pitch this to you guys. Basically, the idea here is if you are trying to get your organization set up with OpenTelemetry, and it does seem like a bit of a struggle, and you would like some professional help, we're dipping our toes into trying an OpenTelemetry quick start service here at Lightstep. So the basic idea here is this is just like a single engagement. This has nothing to do with buying Lightstep as a product, by the way. Like you don't even have to use Lightstep if you'd like to do this engagement. This is just purely to get access to our engineers and customer service folks, and they will help you in an actual hands-on approach to rolling OpenTelemetry out at your organization. So it looks like we're charging $6K for that experience right now. If you are interested in getting some actual hands-on help with rolling out OpenTelemetry, just contact support@lightstep.com, or just get a hold of us anyway and mention that you're interested in this service. I'm personally curious to see how interesting this might be for people. But again, just to clarify, this is not something that is going to require you getting a long-term contract with Lightstep or anything. It's just an engagement around OpenTelemetry, since we're so involved in that project. Great. Oh my God, I'm not screen sharing. I'm such a jackass. Okay. Oh. Well, good thing I gave everyone a link to the slides, right? Yeah. Okay. Well, I did have some slides, but these slides, whatever. These slides are whatever. They're just saying the words that came out of my mouth. So don't worry about those. This slide actually is describing this quick start thing that we're offering to people. So maybe that was a useful slide. But the rest of the slides just had some words. So you didn't miss anything. You didn't miss anything. Okay. And again, you know, you can look at these slides yourself. And that's all we have for this workshop. So just a final cheat sheet here to sort of go over the current state of OpenTelemetry. At this point, in my opinion, the languages that are still in beta, but production ready for early adopters. You can roll this out in production. You just may have to deal, you know, with some instability around the APIs. If you're leaning heavily on auto instrumentation, though, that shouldn't be much of a problem because you're not maintaining that instrumentation code. But the 4 languages I recommend for production right now are Go, Python, Java, and JavaScript. I believe Erlang is also ready. I am not close enough to that SIG to be able to judge that, but Erlang's another one that you can check out. And C# is coming along really well as well, as is C++. And after that, you'll probably see Ruby and PHP maybe being the next languages to get to a production-ready beta. But right now, it's these 4. If you're looking for chat and help, this is actually post this into the chat as well. We've also started up a Discord server. So I did mention you can hop onto Gitter and ask the OpenTelemetry community questions, but you can also hop onto the Lightstep Discord, and we're all hanging out in there, and you can ask us questions about OpenTelemetry as well. So that's another place. If you want to follow up with this workshop, we'll be hanging out in that Discord. And we're happy to answer questions there. So that's another place to find help. 2 websites that are really useful: OpenTelemetry.io. That's of course the core OpenTelemetry website. From there, you'll find links to API docs. The docs, for the record, actually all live in the GitHub repos, but you know, you can find a link to that from OpenTelemetry.io. There's also OpenTelemetry.lightstep.com. So these are docs I am personally putting together. So this is going to be a lot more like getting started guides and things of that nature, and shoring up the API docs. So that's, you know, OpenTelemetry.lightstep.com. So this is me. And so if you want to check out how to do this setup after the fact, I've got a setup guide that's similar to what we were just walking through. And I'm going to be adding a lot of information to this over time. So do check that out. I would love feedback on what kind of content people are looking for beyond like the core docs that OpenTelemetry has. In particular, I'm looking at framework guides and cookbooks and things like that. So I would love feedback onto what kind of additional information is useful for people. And if you want to get updates about all of this stuff, you can follow me on Twitter. I don't tweet a super amount, so you're not going to get spammed, but I will try to tweet on a regular basis around updates to all of these resources and OpenTelemetry in general. So that's a way, if you're on Twitter, to kind of keep abreast of this stuff. And that is all we have. So thank you so much for joining.